For decades, Colombia was never seen as a major player in next-gen air combat. But that perception shattered when the nation quietly unveiled its involvement in Japan's revolutionary sixth-generation stealth project, unofficially dubbed the Godzilla Jet. With cutting-edge features like microwave missile defense and AI-powered drone wingmen, this isn't just a fighter, it's a battlefield disruptor. How did Colombia get involved? What makes this jet so feared? Join us as we uncover how Colombia's Godzilla T-33 stealth fighter just shocked the world. At the start of the year, Colombia made headlines with one of its most ambitious defense moves in decades. The country announced a $3.9 billion agreement to acquire a fleet of Gripen fighter jets from Sweden's Saab. This decision will overhaul Colombia's air combat capabilities and redefine its role in regional security. Deliveries have begun, with 2 jets appearing at the prestigious Rio Negro Air Show in Antioquia in July. This marks a turning point for a military still operating decades-old Kfir aircraft. The Colombian Air Force is not just replacing planes, but stepping into a new generation of warfare. And the Gripen is no ordinary upgrade. The Saab Gripen is a multi-role combat aircraft designed for speed, agility, and adaptability. It's built around versatility, capable of switching between air-to-air, air-to-ground, and reconnaissance missions in a single sortie. This swing role functionality allows it to shift missions on the fly, responding to new threats with a cockpit optimized by its onboard computer systems. What makes the Gripen particularly effective is its aerodynamic design. It features a delta wing paired with forward canards, giving it high maneuverability and exceptional control even at low speeds or extreme angles of attack, up to 80 degrees. This design, paired with fly-by-wire digital controls, allows for tight turns, quick climbs, and evasive maneuvers that would challenge many fourth-generation aircraft. Speed and power are just the beginning. The Gripen is equipped with the PS-05/A radar system, which can track multiple targets simultaneously and guide a range of beyond visual range missiles. This radar, paired with the aircraft's electronic warfare suite, allows it to detect, jam, and evade threats while keeping the pilot fully informed in complex airspace. The jet supports a wide array of advanced weapons. It can carry the MBDA Meteor, a long-range air-to-air missile considered one of the most capable in the world. It's also compatible with the Iris-T short-range missile, AGM-65 Maverick for precision ground attacks, and the RBS-15 anti-ship missile. On board, a 27mm Mauser BK-27 cannon provides rapid-fire capabilities for close-range combat, although this is omitted in some trainer variants. The Gripen can carry more than 6,500 kilograms of weapons and gear, equipped with over 10 external hardpoints. Optional pods can be mounted for reconnaissance, targeting, or jamming operations, such as the Lightning Targeting Pod, Saab's modular reconnaissance system, or radar jamming tools like the Bright Cloud Active Decoy. The aircraft's survivability suite includes missile approach, warning sensors, and electronic countermeasures, giving pilots early alerts to counter incoming threats. Operationally, the Gripen was designed for speed in the air and on the ground. It can be refueled and rearmed by a small team in under 10 minutes, allowing for rapid turnaround between missions. It can take off from short or damaged runways, including remote airstrips, and is reinforced to handle rough landings. These features make it ideal for operations in challenging environments like Colombia's varied terrain. Its Volvo RM12 engine is a modular power plant derived from the proven GEF 404, offering high thrust and durability with low maintenance needs. The design has emphasized sustainability for decades, with Saab aiming for a 50-year service life supported by consistent updates and system flexibility. The Gripen's open architecture allows for easy software integration, meaning Colombia can upgrade the aircraft as new weapons and technologies emerge without needing to overhaul the platform. The aircraft is also fully compatible with NATO standard communication systems. It can link with satellites, drones, and allied units through encrypted channels such as Link 16 and Rover, allowing real-time data sharing across multiple platforms. This feature makes the Gripen a powerful multiplier in regional operations, joint exercises, or coalition missions. Colombian defense officials see the Gripen as a strategic response to growing regional tensions. As neighboring countries expand their fleets and invest in new technologies, maintaining air superiority has become more than a matter of pride. It's about deterrence. The Air Force has stated that Colombia cannot rely on outdated systems to defend its airspace, especially with the increasing role of drone warfare, electronic attacks, and long-range missiles in modern conflicts. However, the decision has not been without controversy. Many Colombians, particularly in political and civil sectors, have voiced concern about the timing and cost of the deal. With the country facing persistent issues in education, public health, and economic inequality, critics argue the government should focus on domestic welfare before allocating billions to defense. The Petro administration has defended the move, stating that the payments will be spread over multiple years to ease financial pressure. Officials have also pointed to the long-term benefits, including limited partnerships with Saab that could eventually strengthen Colombia's aerospace industry. While the jets will be manufactured entirely in Sweden, the agreement leaves room for future technology sharing and potential local integration of upgrades. Some critics have questioned why Colombia chose Sweden as a supplier, bypassing more traditional defense partners like the United States. But analysts say the decision may be strategic. By working with Saab, Colombia gains more flexibility and avoids dependency on one nation's military supply chain. Saab also offers export partners access to technical documentation and software code, allowing for greater control over long-term support and modifications. While headlines focus on the arrival of the Gripen, quiet conversations behind closed doors hint at something even bigger. Rumors suggest Colombia is already looking beyond its Swedish fleet, setting its sights on Japan's next-generation stealth fighter, the Godzilla FX fighter jet. The FX isn't just Japan's next fighter jet, it's a declaration of future air dominance, a twin-engine stealth aircraft designed with one objective: absolute superiority in the skies. According to Japan's Ministry of Defense, its performance pushes it beyond today's most advanced platforms, placing it firmly in the sixth-generation category. Larger than the American F-22, the FX isn't built for show. Its size allows for greater range, heavier payloads, and superior onboard systems. Much of its foundation comes from lessons learned during the X-2 demonstrator program, but the FX represents a leap forward in almost every direction. Every part of the aircraft begins life in a digital lab. Engineers simulate combat scenarios using 3D models and pilot feedback. Virtual dogfights expose weaknesses and shape improvements long before the prototype is built. Each change is stress-tested in high-fidelity simulations to ensure it performs under pressure. The FX integrates a network of sensors to detect stealth targets: AESA radar, infrared tracking, and passive RF detection. These systems are powered by gallium nitride semiconductors, boosting sensitivity and reliability. The FX not only detects threats at an extended range, but does so without giving away its position. Its defensive systems act instantly. Radar locks and incoming missiles trigger automated jamming protocols. Antennas embedded within the skin intercept threats and respond before human pilots even react. Stealth lies at the core of its design. There are no hydraulic systems, only electric actuators. These reduce weight, increase reliability, and help maintain the clean internal layout needed to avoid detection. The airframe features serpentine ducts and an internal weapons bay to eliminate radar reflections. Engine nozzles are coated with carbon-based material to absorb electromagnetic waves, further shrinking radar visibility. The jet also uses metamaterials, composites engineered at the microscopic level to bend and scatter radio waves. These materials work in tandem with a wave control system, rendering the FX nearly invisible until it decides to strike. The FX relies on passive detection systems and advanced sensor fusion to remain hidden. When radar must be used, it emits signals using low probability of intercept techniques. This electronic discipline allows it to operate freely in environments saturated with enemy sensors and missile threats. A breakthrough lies in the plasma stealth antenna system. It manipulates plasma fields to obscure radar reflections while still transmitting secure communications. This innovation gives the FX a decisive advantage, remaining undetected without going silent. Electric actuation replaces the complexity and vulnerability of traditional hydraulics. These systems are more flexible, resilient under combat conditions, and easier to maintain. They power key control surfaces and braking mechanisms, delivering precise response with reduced system weight. To streamline construction, the FX uses a fastener-less composite structure instead of mechanical fasteners, and adhesives bond carbon fiber materials into integrated components. This not only cuts weight but also reduces production time and complexity. Heat-resistant alloys are placed strategically to protect against thermal stress near the engines. Simulation tools like finite element modeling allow engineers to optimize every component. According to Japan's Ministry of Defense, the mid-fuselage section alone saw an 11.6% weight reduction and a 66% cut in production labor. Rare feats in fighter development. Cooling is another major hurdle. High-powered electronics and dense avionics demand robust thermal control. A vapor compression cooling system combines air and liquid to prevent overheating, even during extreme performance or in hot climates. At the heart of the jet is the XF-9 engine, a new benchmark in military propulsion. Each unit produces over 33,000 pounds of thrust with afterburners and is designed to exceed 44,000 eventually. Despite this power, the XF-9 remains compact, 30% smaller in intake diameter than the F-2's GE F-110 engine. This allows all weapons to be carried internally, preserving stealth. Each XF-9 engine also generates 180 kilowatts of electrical power, 380 kilowatts in total. This surplus powers the FX's advanced systems and lays the groundwork for future technologies, including directed energy weapons and next-generation jammers. Agility is enhanced through 3D thrust vectoring nozzles, which deflect exhaust up to 20 degrees in any direction. This improves dogfight maneuverability and missile evasion. At the same time, the nozzle design suppresses infrared emissions, protecting the jet from heat-seeking weapons. In December 2021, Japan signed a landmark agreement with the United Kingdom to co-develop a demonstrator engine, combining IHI Corporation's experience with Rolls-Royce's profound expertise. Later, Italy's Avio Aero joined, turning the project into a tri-national endeavor. Together, the three nations aim to build an engine not just for flight, but for a new era of warfare. This engine will meet the extreme power and thermal demands of sixth-generation avionics, sensors, and future combat technologies. It will be compact, energy-efficient, and durable, ready for the battlefield of tomorrow. Weapon integration is another frontier that the FX is already preparing for. Among its primary armaments will be the ASM-3, a high-speed air-launched missile developed for Japan's F-2 fighter, but now destined for the FX. The ASM-3 gives the jet long-range strike capabilities with high survivability, offering an ideal blend of speed and lethality as older platforms are gradually phased out. But beyond conventional missiles, the FX introduces a far more futuristic asset, a microwave-based directed energy weapon designed to neutralize incoming missile threats. This high-powered microwave system is not mounted as a separate cannon or pod. Instead, it's cleverly integrated into the jet's AESA radar system, activated through electron tube amplifiers that are both miniaturized and highly efficient. The result is a stealth fighter that can fry the electronics of incoming threats mid-air without compromising its stealth profile or maneuverability. As Japan lays the groundwork for the FX, it also prepares a whole ecosystem of support systems that will redefine how future air combat unfolds. At the center of this evolution is an ambitious unmanned systems program known as Combat Support Unmanned Aircraft, a project designed to bring loyal wingman drones into real-time coordination with manned fighters like the FX. These drones are built for flexibility. One variant focuses on sensing and reconnaissance and is equipped with sensors to detect, track, and designate targets from afar. The other version is weaponized, able to launch munitions or divert incoming fire, essentially acting as a shield for the FX. Despite having different operational roles, both drone types share the same basic airframe, reducing production complexity and allowing for interchangeable deployment strategies depending on mission requirements. This concept mirrors ongoing programs like the Kratos XQ-58 Valkyrie in the United States and Boeing's air-power teaming system. Still, Japan's approach emphasizes deep integration with the parent aircraft. The FX will act as the command hub, coordinating real-time tactics between manned and unmanned assets. This level of coordination will allow the FX to engage threats from multiple angles, saturate enemy defenses, or perform high-risk operations without endangering its pilot. Development of these support drones is underway, with full deployment expected by the 2030s, lining up with the FX's projected operational timeline. The fighter and its unmanned companions represent a shift toward networked warfare, where machines and pilots operate as one seamless unit. As Japan finalizes its design, tests propulsion systems, and scales up drone development, it is clear that the FX is more than a stealth fighter. It's the centerpiece of a next-generation aerial combat system, stealthy, intelligent, and supported by artificial intelligence-driven drones and electronic weapons. The origins of Japan's FX fighter program began not in a laboratory or factory, but in Washington. In 1997, the U.S. Congress passed the Obey Amendment, which blocked the export of the F-22 Raptor, then the world's most advanced fighter jet. Japan had sought the Raptor to modernize its air fleet. The request was denied. For Tokyo, that decision became a turning point. Cut off from acquiring the aircraft, which was believed to be essential, Japan made a choice. It would build its own. In 2009, the Ministry of Defense began a formal study on developing a next-generation fighter. The mission was bold. The new jet would not just match current fifth-generation aircraft, it would aim beyond them. It would be a sixth-generation stealth fighter, designed and led by Japan. The concept was called the I-3 fighter, for informed, intelligent, and instantaneous. It would connect with drones, ground systems, and airborne early warning aircraft. It would have radar strong enough to detect stealth targets. It would use gallium nitride semiconductors to increase radar power and clarity. Its controls would rely on flyby optics instead of traditional wires, processing vast amounts of information faster than ever. It would be fast, evasive, and aware. And it would be entirely Japanese. Japan needed to close a century's worth of technological gaps to build such an aircraft. The path forward began with the Mitsubishi X2 Shinshin, a demonstrator jet created to test and develop critical systems. The X2 first flew on April 22, 2016. After 2 years of test flights, Japan had gained the data it needed to take the next step. Japan invested in various focused research projects from 2009 onward. These were not experimental guesses. Each effort targeted a key system the fighter would need. Japan developed advanced sensors to detect stealth aircraft. It tested weapon bays that could open and release missiles at supersonic speeds without disrupting flight stability. Engineers worked on a lightweight but high-thrust engine, capable of powering not just flight, but onboard energy weapons and electronic systems. The XF-9 engine was born from this research, a compact but powerful core for the future fighter. In other labs, Japan explored how to defend against modern threats. It developed electronic warfare systems to jam or mislead missiles. It tested microwave weapons, designed to disable incoming threats before impact. It studied infrared imaging, thrust vectoring nozzles for extreme maneuverability, and airframe materials that could reduce weight without compromising strength. All this was more than theory. In 1929, Japan conducted test flights using F-2 aircraft fitted with experimental sensors meant for the FX. The results were promising. Japan was now preparing to move from concept to design, but the scope of the task ahead remained immense. Japan reached out to allies. In 2017, Tokyo and London signed an agreement to explore joint development. By 2018, Japan considered building its fighter alone, partnering with allies, or modifying an existing foreign design. Offers came in. Boeing proposed an upgraded F-15. BAE Systems offered a version of the Eurofighter Typhoon. Lockheed Martin proposed a hybrid of the F-22 and F-35. Northrop Grumman expressed interest, sparking speculation that it might revive its long-abandoned YF-23 Black Widow design. Japan listened, but was not convinced. The Ministry of Defense rejected all three proposals. Existing fighters could not meet Japan's demands for stealth, speed, and future growth. Lockheed's F-22/35 hybrid was powerful, but too expensive. The U.S. was still unwilling to loosen export restrictions. By early 2019, Japan declared it would lead the program itself. The FX would be Japanese and built at home, But international partners would still be welcome on Japan's terms. Mitsubishi Heavy Industries was placed at the helm. The Acquisition, Technology and Logistics Agency formed a dedicated FX team, led by a JASDF Major General and staffed with elite engineers and officers. Subaru Corporation established a new tech center to support the effort. The first prototype would be built by 2024, and flight testing would begin in 2028. Full production would follow by 2031. Japan had allocated over 28 billion yen to launch the program by 2020. A new fighter image was released, and the project officially became FX. Its design would allow rapid upgrades, modular components, and compatibility with future unmanned systems. It would be the heart of Japan's air defense into the mid-21st century. Then in late 2022, the FX's future took a new turn. Japan, the United Kingdom, and Italy announced a merger of their fighter projects. The FX, the UK's Tempest, and Italy's sixth-generation concepts would combine into a single multinational program, the Global Combat Air Program. This historic decision marked the end of the FX as a standalone national project, but it was not a retreat. It was an evolution. Japan would bring its technologies, sensors, engines, and microwave weapons to the global table. Together with Rolls-Royce and Leonardo, Japan would now help shape the future of air combat on a much larger stage. From denied access to U.S. technology to forming one of the decade's most advanced international defense programs, Japan's fighter story is no longer about catching up. It's about leading. Production of the prototype was expected to begin in 2024. Flight testing will follow in 2028. Mass production is planned for 2021. Thanks for watching. While you're still here, click on the link appearing on your screen to check out another of our videos. See you there.